Assalamualaikum everyone. Today we are going to talk about the digital parking control system. In the question, we have shown a circuit or demo picture of the system that we are going to make. Today we have given task four tasks actually. So one is the outline, the essential step in the appropriate sequence and develop block diagram. So in total, we have to display the full and space available these two segments in our system with the structure and the foundation of this parking system. And in the second question, we have to calculate the display about two triple five timer we are going to use to show the full and space available to display. We are going to find a P and a duty circle and THTL. They have time high and time low. There are three capacitor are given 50, 250, and 470. We are going to calculate that later. In the third question, we have to prepare a FSM with TH and TL. Uh, if the TH and TL, TH and TL are greater than 4, we are going to make it 4 as the final one to make FSM. And in the fourth question, we are going to identify the limitations or drawback of the found system I have created or calculated. And we are going to say about what can we do better to make what can we do to make it better as a system, and what kind of motivation do we need. And we have to analyze it specification change of the system. And let's go to the to question one. In question one, my idea are given 2351093, and the more max car capacity is 6, as the taken A plus G plus is 2, 3, and 1. And we have used an encoder 8 into 3, and I have shown two diagram of asynchronous and sorry, I have shown two triple five timer, stable and monostable. In the flow diagram, I have shown the sequence of the system that going to be passed around, and from the start to end, I have the sensor, encoder, up-down counter, comparators, and we have used Bool to identify the truth and false in five-time counter, and monostable and triple five timer display to display full and display space available. After the exit entry, we have end the flow diagram. And in last, I have shown a 3-bit asynchronous up-down counter. Uh, Here I have used a same clock for as a synchronized up-down counter as all the input are high. And in the second question, there are calculation part that I have to do. And for the triple five timer calculation as stable, duty cycle D is equal to 100 minus P. And the P I have taken as A plus C plus D plus E plus F into 2. Because of I have the 0 in E, so I have to replace it with A plus B and H. So it's 6. So total, after replacing the E 0 to 6, I have got 2 plus 5 plus 1 plus 6 plus 9 into 2 equal to 46. The duty cycle I got is 54. The frequency I got is 6, 5 hertz as A plus D plus 2. And T is the inverse of F, so I divided 1 by 5, 2.2 equal to 200 ms. In the duty cycle, we know the formula, the time high divided by time high plus time low. And we can say that time high plus time low is totally the T. So TH divided by T are the duty cycle. So TH I can get which is 108 ms and the T low is 92 ms. In the display, uh, we can find the R2. The for the R2 I have to for the R2 I have to find it from TL as the lowest number, which is 2600 655.12 ohm. For the R1, I have to find it from T high, time high, then it will be minus by from R2, and which is 461.7 ohm. For the it was for the capacitor 50 capacitor 50 micro ohm. Yeah, microfarad, yeah, farad. And for the capacitor, for the capacitor 250 microfarad, R2 I had got 531.02, and R1 is R 92.35 ohm. For final the for capacitor 470 microfarad, yeah, R2 equal to we got 282.45 ohm, and R1 we got 49.13 ohm. For the capacitors 50, 250 and 400, 470, we got the this result which is not the accurate, I think, because of the duty cycle I have got and the TH I have got from there. Because I R1 is getting bigger than R2, which was not going to happen because of the ID number. It happens actually. In question and answer number three, I have TH is equal to 132 and TL equal to 68, which are bigger than 4. So to find to do the FSM, I have to determine the actual number 4 as a constant and do the state diagram. In the state diagram, we can see A from 4A to 4B, and reset is 000. In the state diagram, there are reset only one, and P state and N state as the next state, and output A and B. There are four output A, and in last there are four output B. We can show the equation. In the equation, next state 0. Next state 0 equal to reset bar. As we can see the equation, there are they are taken P2 bar into P1 bar into P naught bar plus P2 bar into P1 into P naught bar plus P2 point P1 bar into P naught bar plus P2 into P1 into P naught bar. Like this, we have got N1 and 2 and A and B output and P and P bar format. In the Verilog HDL code, we have two internal signal definition as regular and wire, and we have done next state logic assigning n state 0 and state 1 and n state 2 as assigned, and in the present state always at the positive eighth clock begins at P state 0, P state 1, and P state 2 always smaller than N state 0 and state 1 and state 2. In the end, the output logic is assigned A, and output logic is output logic is assigned B. That's how I end the question number 3 with N module. In the answer number 4, I have found some limitation of this current design, the design I had made. The sorry about that. The limited capacity, the capacity number, yeah, the limited capacity. The car number only 6 from my ID. It can be bigger with every bit I use. like 8-bit or 9-bit can be used for many cars to hold in the parking system. And sensor bounce and false trigger are also happens. The power backup issue happens when the load sharing in our country happens. The power fails, reset the whole system and deletes the car count it has previously stored. That's why many things can be happen. Car place was full, but it was shown empty. That kind of situation can be happen. And triple five time limitation. There are triple five time limitation like there are stable triple five cannot be on or off by logical input. The monostable cannot hold indefinitely and needs to continuously trigger on logic override. Possible solution I have found to use of a non variable sorry use of smart memory to store the count even when the car count are reset. Use the and the second one is use the power battery to restore to at least backup for some moment to continue the count and the use of smart memory to back up the data. We can use a BCD computer with a display decode for direct output to 7 segment 2351093 as my ID display. We can add an AND gate to enable and disable the triple frame timer output also. So for the higher capacity of car, as we can see, if, 255 8 volt, one is encoder 8-bit can be used, counter 8-bit can be used, and converter 8-bit can be used. Thank you, everyone. That's for all for today.